Welcome back. Let's take a look at some of these answers, but I do want to make sure that you pause this at some point and really look through and check to see how you did on each of these. So notice every single equation has two solutions, and I want to discuss showing your work appropriately. This is what I would consider showing your work well. Here, showed my work factoring and what my factored form is. I also showed my work by setting each parenthesis equal to 0. Okay. Now, hopefully you realized at a certain point that when we had simple quadratic equations with just like an x plus 6, x minus 1, the solution was always just the opposite of what was in your parentheses. And so if you want to skip showing the x plus 6 equals 0, the x minus 1 equals 0, that part, I'm okay with that. But your homework cannot just be boxed solutions. You have to show your work on your test in your homework, or you will not receive full credit. And again, what I've highlighted here is what I would consider the minimum of showing your work. Okay? Okay, so that's our first couple cases, factoring by greatest common factor, and when we have a quadratic trinomial where the leading coefficient is 1. Let's solve some more, but this time our quadratic trinomial is going to have a number in the front. So just a quick review of that. Remember, we have to multiply our first coefficient and then our last constant. And we're going to ask ourselves what multiplies to that and adds to the middle number. Then we're going to rewrite our quadratic. And this time when we rewrite it, we're going to use these two new numbers we came up with. And then we will factor that new format by grouping. So we group front two and last two, and when we use grouping, we use greatest common factor. Then we'll set it equal to 0, and then we'll solve. If we're going through this and it feels way too fast for you, what you're going to need to do is go back to the review video about how to factor with a leading coefficient other than 1. Here's our first one. We'll do a couple together, and then I'll ask you to try a few on your own, just like before. All right, so we're going to set this equal to 0, and then I am going to start by factoring. I'm going to ask myself what multiplies to 30 and adds to 17. That would be 15 and 2. So now I'm going to rewrite this, and I'm going to keep my first term, 5x squared, and I'm going to break down the 17x into a 15x plus a 2x. And then I'm going to keep my plus 6. Now I'm going to group the front two terms and the back two terms together and factor those using greatest common factor. So 5 and 15, I can factor a 5 out of that. There are x's in both parts, so I can factor an x out. When I factor, I divide. 5 divided by 5 is 1. X squared divided by x is 1x. 15 divided by 5 is 3. X divided by x is 1, so it's just x plus 3. All right, now we'll work on our next set of parentheses. 2 and 6 have a greatest common factor of 2. There are no x's in both terms, so I'm just going to factor a 2 out. So that leaves me with an x plus 3. Notice my parentheses match. That's what I was hoping for. That tells me I'm likely on the right track. So I'm going to factor that x plus 3 out of both of these terms and then write down what's left over in my second set of parentheses, 5x plus 2. Now what I have just completed is rewriting 5x squared plus 17x plus 6 in its factored form. You'd like to think we're done, but we're not. Now what we need to do is set each parenthesis equal to 0 and solve. Well, this first one's pretty easy. X plus 3 equals 0. That's just like the ones we did. So this x is negative 3. Negative 3 plus 3 is 0. This other one, I am going to have to show more work for, just like you will in your homework and on your test. So I'm going to subtract 2 from both sides. 5x equals negative 2. And now divide both sides by 5. And then x is also equal to negative 2/5. So these are my two values of x. These are the two places it crosses the x-axis. Let's do one more together, and then I'll have you try a few on your own. All right, we set it equal to 0, and then I multiply my first term and my last term. And I say what multiplies to negative 24 and adds to 5. I'm going to have a positive number and a negative number. Let's think here. 24, that would be 8 times 3. 8 minus 3 is 5, so 8 and then a minus 3. Now I'm going to rewrite this. 2x squared plus, I almost wrote plus 5x. It would be plus 8x minus 3x plus 12. I'm going to group my first two. Now notice that minus 3x, that minus sign needs to stay with the 3. So I'm going to just squeeze a little plus sign in there to show that these two parentheses are not being multiplied. Okay, I'm just drawing in my parentheses. And now I'm going to factor out of the first one. It looks like 2 and x. I could choose to factor out a negative 2 or a positive 2. I think for right now I'm just going to factor out a positive 2. So I can factor out a positive 2x, and then I'd have a negative x plus 4. Plus, now remember I want my parentheses to match. So when I'm looking here at my two terms, I can factor out a 3 or a negative 3. But I'm going to want to have a negative x in the parentheses, so I'm going to want that negative to stay in there. I'm only going to factor out the positive 3, and that will leave me with a negative x plus 4. My parentheses match, so now I'm going to factor out the negative x plus 4, and then I'll have my 2x plus 3 left over. Set that equal to 0, and now I'm going to solve. Right here, negative x plus 4 equals 0. There is a little bit more thinking to that. Negative x plus 4 equals 0. If I subtract 4 from each side, that leaves negative x equals negative 4. So positive x is positive 4. Hopefully you can do that in your head, but if you can't, that's my explanation right there. All right, 2x plus 3 equals 0. Subtract 3. And then divide by 2, running out of space. All right, and so my two solutions, let's write this nice and neat, are 4 and negative 3/2. All right, take some time, try these next 3 on your own, and then in video 3 you can check your answers, and we'll wrap things up by looking at some special cases.